Hello everyone. Today we discuss about some standard section shear stress distribution. So in the previous class we have derived some relationship between the shear stress, shear force, and shear stress distribution among the some standard sections like rectangular section, circular section, and the um, triangular section, isosceles triangular section. But we have some standard section like I section and L section. So how the shear stress will be distributed along this throughout this I section, T section, this symmetrical and symmetrical section. So first thing, starting to this shear stress distribution section, we know the value of y bar. We want to formulate or drive the value of y bar and area, and also one more thing is the I. So because we know the value of shear stress will be equal to f upon may b into I into multiplied by a into y bar. So let take example of I section. So here what is the parameter given? The shear stress, draw the shear strain of the I section, and it is successful to shear force of 100 kilonewton. So here the magnitude of shear force is given and section is given. So we want to we just calculate the this distribution. We want to draw the question asked about the drawing of this shear stress distribution. So let's start. First, due to the symmetrical, we calculate the value of this I. So you know the formula of I, bd cube by 12 plus a into y square on the perpendicular axis theorem. So area, so here we distributed this I section into three rectangular, 1, 2 and 3, and we take from the CG bottom. So due to symmetrical, the neutral axis is lie on the this mid of this particular section. So we know need to determine the value of y bar, I think. So 180 into 10 is the bd cube by 12 plus 180 into 10 into 200 minus 5. That means we take this neutral axis here because we know, and from this mid matlab that mean the 10 by 2, that mean 5. So 200 minus 5 is like 195. So here first, then similar to second, which is lie on the neutral axis. So we don't need to calculate this part because 200 minus 200 becomes 0. So just like bd cube by 12. And third one is the similar, so we just put twice for direct calculation. So I is become this, and we know that the maximum value of y is 200 is 0. The shear stress at the y is equal to 200 is 0 because there the shear distribution, the shear stress as the top of the flanges are the extreme fiber which will become 0. So since y bar will be equal to, so this y bar, we take the y bar as the top flanges. So due to this is become 0. The shear stress top flanges will be equal to 0. So shear stress at the bottom of top flange. Bottom of top flange means here the shear stress will be equal to 0. We want to calculate the shear stress at this portion, this 10 mm. So here what is the value of y bar? So we put f we know, b we know, I we know, or area we also know. Area will be equal to 1 into 10. What is the value of this y bar? The y will be equal to, from this CG to this bottom of this fiber. So this value will be equal to 195 from the CG of this particular. So we got the value of 195. So here the value of the shear stress is 1.068. Same thing. So we calculate the shear stress distribution in the flanges. We want to calculate the shear stress distribution on the wave junction with flange. That means this point. So at the junction or the top of this wave, what is the shear value? This value is become constant. So we, and the area is again 180 into 10 and into 195. But here one thing is changed. Here is the B is 180, but here is the V is 10. So due to this difference, we got again one shear stress value on the same point. So that's why this graph is become this trend. So at the top flange, the shear stress will be equal to 0. At the bottom of top flange will be the shear stress will be equal to 1.068, and the junction that means this point, this become 19.217. So now we calculate the at the mid, that means at the maximum point. So at a neutral axis, all thing is remaining constant. What is the area of the neutral axis? Here the area will be considered. That means this area and this area, this half area, this T section will be considered at this neutral axis. So 180 into 10 into y bar 195, and 10 into 200 minus 10 into 190 by 2. So here we get this value a into y bar, area become, here is the area 200 minus 10 into 190 by 2. That means this is become 190 by 2. That means this is y bar, and area is become 10 into 190. Into 190 into 190 by 2. So we combine this both. So at the mid, the values is 29.10, and because this is the symmetrical section, so this same values will be repeat in the bottom side. So the shear stress distribution diagram for this I section is become 1.068, 19.217 at the mid, 29.10, and the same thing is will be repeat here. So it is very easy to calculate the shear stress distribution in the symmetrical section. But when this symmetrical section is not found, or the our question asks about some unsymmetrical section like T section, like you have to want to drive this shear stress distribution along this T section. So here some so the question is some advanced level as this symmetrical section. So in the next class you see the one question. You have I give assignment to you. You must try one questions which is T section at your own. Once if you have doubt, then I will discuss later. So this is the I saw the answer also. You try on your, this is the T section, this is the diagram section. You have to find out the shear stress distribution. The value of the shear force is 25 kilonewton. Okay, thanks.